Welcome to Circuit 4B, where we'll be using this small black three-legged temperature sensor and adding it to our OLED display from last circuit. Sorry if you got used to operating without the breadboard last circuit. It is coming back this circuit, but don't worry, we'll only be adding a few wires. How can we use this sensor to get a useful temperature and display it on our OLED? Let's find out. Our temperature sensor's three legs are power, ground, and signal. The middle signal pin simply outputs an analog voltage, which gets higher as the temperature gets higher. When we connect it to an analog input on our IoT breadboard, we will get back a number of counts that goes up as the temperature goes up. To convert this number of counts into a usable temperature in degrees Fahrenheit, we will use a combination of three equations. First, we want to convert from the counts read by our analog input to a voltage. The function to read an analog input is read U16, where the U16 means this count value is an unsigned 16-bit integer. Unsigned means that our value can only be positive, and 16-bit integer means our value will be an integer from 0 to 65535. Since the top voltage we can read on our analog inputs is 3.3 volts, we know that the top number of counts we can read from read U16, which is 65535, correlates to this 3.3 volt voltage. This gives rise to our first equation. Voltage equals analog counts times 3.3 over 65535. Notice how, if the counts is the maximum value of 65535, the corresponding voltage is the maximum 3.3 volts. If the counts is the minimum value of 0, the corresponding voltage is the minimum of 0 volts. The reason we want to convert from counts to voltage is because the temperature sensor's data sheet has already given us an equation for converting from voltage to temperature in Celsius, so we'll use that next. Degrees Celsius equals voltage minus 0.5 times 100. This will give us the temperature in degrees Celsius. If you're anywhere else in the world, you probably want to stop here. If you're in the United States, we'll use a third equation to convert to Fahrenheit, because we're weird and we like it that way. The standard conversion equation for Celsius to Fahrenheit is degrees Fahrenheit equals degrees Celsius times 9 over 5 plus 32. Using all three of these formulas, we can take the counts read from our analog input and convert them to a temperature in Fahrenheit, which we will display on our OLED. That's about it for theory for Circuit 4B. Now let's build the thing. We'll keep our OLED connected via the quick connect cable in the exact same way as the last circuit. Then, we will simply add our temperature sensor to the breadboard and connect its power and ground to power and ground, and its signal to A5, our fifth analog input. Make sure you have the temperature sensor inserted in the correct way, as it is polarized. Your guide will help make it clear to you which leg is which. Make sure your ground leg is connected to the black wire and to ground, and the positive voltage leg is connected to the red wire and power. Swapping these can make your sensor very hot and can damage it. Now, let's scroll down and run some code. The first code block will set up our OLED and our analog input pin. The second code block will set up functions for getting temperature in Celsius and in Fahrenheit using the equations we just discussed. The last cell will loop and read the temperature and display it on the OLED in both Celsius and Fahrenheit and update them every second. Feel free to breathe on the sensor or put your finger on it to force the temperature to change. Nice job completing the second circuit of Project 4 and designing your own digital thermometer. You can see how our OLED keeps getting more useful as we combine it with other components. When you're ready, move on to Circuit 4C, where we'll take our OLED to the next level by designing a fun game.